Hi everyone, myself B. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today my topic name is Inverse Laplace Transform of Shifting Operators. Previously we discussed in the last sessions Laplace transform shifting properties. What is the difference between inverse Laplace transform and Laplace transform is Laplace transform converses the inverse Laplace transform. But how we are differentiate both means here, for example, here in the Laplace transform, we are taking the transformation Laplace of f of t is equal to f bar of s. We are considering like this, Laplace of f of t is equal to f bar of s. But in the inverse Laplace transform, that is Laplace inverse of f bar of s is equal to f of t. Here t transform to s, but here s transform to t. That's the difference between Laplace transformation and inverse Laplace transformation. And the properties are similar to the Laplace only. But here we discussed today, the topic is inverse Laplace transformation shifting properties. There three properties are there. First one, inverse Laplace transform first shifting theorem or property. And the second one, inverse Laplace transform second shifting theorem. And the third one is change of scale property. These are the three topics related to inverse Laplace transform. These three are there in the Laplace transform also. But what is the difference between these are all we will discuss now. Then the first property, inverse Laplace of first shifting theorem. If Laplace inverse of f bar of s is equal to f of t form, then Laplace inverse of f bar of s minus a is equal to e power at into f of t. This is the first Laplace first shifting theorem. That is, if Laplace inverse of f bar of s is equal to f of t, for that case we have to consider Laplace inverse of, if the given function in terms of f bar of s minus a, that is equal to e power at into, simply will write that is e power at into f of t. But here, what is the exponential coefficient a here in the function s minus a? In that s minus a value as, here we have to substitute that as e power at into f of t. Here always s minus a is greater than 0. Here always s minus a is greater than 0. This is the first shifting theorem on inverse Laplace. Let us start with the problems. We will discuss with the problems on first shifting theorem. First question, find inverse Laplace transform of s minus 5 by s square plus 6s plus 13. Once you observe the question, here directly given the question as Laplace inverse of s minus 5 by s square plus 6s plus 13. Once you see the question, here how we are using the first shifting operator. First shifting theorem. Is there any condition is there in the question? They are not given any condition in the question. Directly given question is in the form of find the inverse Laplace transform of s minus 5 by s square plus 6s plus 13. Okay, now for that convenience, let us assume what is the function here. Here the function as s minus 5 by s square plus 6s plus 13. Now I'll convert the function as f bar of s minus a. Why? Because once you see the previous slide, what is the property here? Laplace inverse of f bar of s minus a is equal to e power a t into f of t. Now we have to convert the given question as by using first shifting theorem. Laplace inverse of f bar of s minus a is equal to, now I'll write simply that as in e power at into f of t. But how I'll convert? Okay, how I'll convert? Once you see here, the direct question is s minus 5 by s square plus 6s plus 13. For our convenience, now I'll write the function as numerator. I'll convert that as s plus 3 minus 8 by I'll convert the denominator as s plus 3 form, that is s square plus 6s plus 13. I'll write simply 9 plus 4. Okay, simply I'll write that as s plus 3 minus 8 by s square plus 6s plus 9 plus 4. Okay, this is the then that is equal to, simply I'm writing this, s plus 3 minus 8 by, once you see the denominator here, what is the form of the denominator? Once you observe the first part, let us assume this as a square plus 2ab plus b square form, right? For that, I'm taking this as simply s plus 3 whole square plus 4. Okay, simply I'm taking that as s plus 3 minus 8 by s plus 3 whole square plus 4. Once you see, for the given question, now I'll convert that as s plus 3 minus 8 by s plus 3 whole square plus 4. Is there any changes for the question and after I'm converting? There is no changes. This is equal to this only. Okay, then next step. Once you observe here, after taking like this, I'll take Laplace inverse of, okay, how I'll convert in the previous slide here s plus 3 minus 8 by, okay, s plus 3 minus 8 by s plus 3 whole square plus 4. Now I'm taking like this. After that, now I'll convert this as Laplace inverse of s plus 3 by s plus 3 whole square plus 4 minus 8 by s plus 3 whole square plus 4. Laplace inverse of, simply I am taking here s plus 3 by s plus 3 whole square plus 4 minus 8 by s plus 3 whole square plus 4. Okay, next step, simply I am taking this as Laplace inverse of s plus 3 by s plus 3 whole square plus 4 minus of Laplace inverse of 8 by s plus 3 whole square plus 4. Okay, now for the next step, now I'm taking like this, Laplace inverse of s plus 3 by s plus 3 whole square plus 4. Here I'll take 8 as 4 into 2 by s plus 3 whole square plus 4. Laplace inverse of 4 into 2 by s plus 3 whole square plus 4. For the next step, now I'm taking like this, that is Laplace inverse of s plus 3 by s plus 3 whole square plus 4 minus, I'll take 4 outside and the remaining part here, wait, minus, I'll take 4 outside, 4 into Laplace inverse of 2 by s plus 3 whole square plus 2 square. Okay, that is Laplace inverse of s plus 3 by s plus 3 whole square plus 4 by minus 4 into Laplace inverse of s plus 3 whole square plus 2 square. Okay, next step. Okay, once you see, after separating each and every term, okay, now again I'll write the last step here. Why? Because it is not clear there. That is Laplace inverse of s plus 3 by s plus 3 whole square plus, I'll write 4 as 2 square form, minus 4 into Laplace inverse of 2 by s plus 3 whole square plus 2 square. Okay. Now, by using first shifting theorem, what is the theorem statement here? Once again, I'll write that theorem statement, that is Laplace inverse of f bar of s minus a is equal to e power at into f of t dt. This is the first shifting theorem property. Okay, once you see the above step here, Laplace inverse of s plus 3 by s plus 3 whole square plus 2 square means what is the form of this? Which is in the form of Laplace inverse of f bar of s minus a form. Okay, but here what is a? Okay, that is Laplace inverse of s minus of minus 3 by, okay, by s minus of minus 3 whole square plus 2 square minus 4 into Laplace inverse of 2 by s minus of minus 3 whole square plus 2 square. Why I converting each and every time? Why? Because here the formula is f bar of s minus a. Okay. If you are confusing with this step, directly write down here a as minus 3. Okay, na? That means, okay, then now this is equal to here. What is a? What is a here? Minus 3. That means here the question has Laplace inverse of f bar of s minus a is equal to, okay, e power at into f of t form. Now I'll convert the question as Laplace inverse of f bar of s minus a by using the first shifting theorem, that is equal to e power at into f of t. That means for the first part here, what is a? That is e power minus 3t into e power minus 3t into remaining part as, okay, that is simply, what is the formula of, here I am writing that Laplace inverse of s by s square plus a square, that is equal to what? Cos at. And simply, and Laplace inverse of 1 by s square plus a square, that is a by s square plus a square is equal to sin at. Okay, I'm using these two formulas. Okay, that is Laplace of s by s square plus a square is equal to cos at. That means after taking the exponential form, remaining part as f of t form. That means the f of t form is, after writing the exponential, that is Laplace inverse of s by s square plus a square form. For that, what is the formula here? A means 2, that is cos 2t. Minus 4 into Laplace inverse of a by s square plus a square. First, I'll write that as exponential form by using first shifting operator. That is first shifting theorem. That is here, what is a? First, I'm writing that as e power minus 3t into remaining part as Laplace inverse of a by s square plus a square. That is simply sin 2t. Therefore, here what is common? These are the formulas. And what is common here? E power minus 3t is common and the remaining as cos 2t minus 4 into sine 2t. This is the final answer for the first question. Is it clear, all of you? Here we are using two properties. First, I am using first shifting theorem property. After that, Laplace inverse basic formulas. From the basic formulas only we got the answer, that is e power minus 3t into cos 2t minus 4 into sin 2t. That's the final answer. Next question. Find inverse Laplace transform of 2s minus 3 by s square plus 4s plus 13. Okay, here also given question directly 2s minus 3 by s square plus 4s plus 13. But how we are using the first shifting theorem directly given? Is there any question? Condition is there in any question? Okay, first shifting theorem or second shifting theorem, there is no condition in that question. Directly given, find inverse Laplace transform of 2s minus 3 by s square plus 4s plus 13. Okay, by using from the given question, now I'll convert the given question as 2s minus 3 by s square plus 4s plus 3, not 3 here, that is 13. Okay, for that, okay, now for our convenience, now I'll convert the function as 2s plus 4 minus 7 by s plus 2 whole square plus 9. How I'll convert? Once again, I'll write the same step here. That is 2s minus 3 by s square plus 4s plus 13 is equal to, that is 2s plus 4 minus 7. 4 minus 7 means how much? Minus 3 only. That means there is no changes in the numerator. Okay, and next s square plus 4s, okay, plus 9 plus 4. I'll write simply that as 9 plus 4 is how much? 13. Okay, there is no changes in the denominator, but for our convenience, now I'll divide that as s square plus 4s plus 9 plus 4. That is 2s. Here what is common in that first 2? That is 2 is common, that is 2 into s plus 2 minus 7 by, okay, here I am using one formula for the denominator, that is s square plus 4s plus 4 plus 9, that is 2 into s plus 2 minus 7 by, which is in the form of, once you observe the first part of the denominator, that is s square plus 4s plus 4, that is in the form of a square plus 2ab plus b square, that is a plus b whole square, that is s plus 2 whole square plus 9. Okay, 2 into s plus 2 minus 7 by s plus 2 whole square plus 9. Okay, next step. Next, okay, that is Laplace inverse of 2s minus 3 by s square plus 4s plus 13 is equal to, in the above step, that is Laplace inverse of 2 into s plus 2 by s plus 2 whole square plus 9 minus 7 by s plus 2 whole square plus 9. Okay, now that is equal to Laplace inverse of, I am applying Laplace inverse on both the terms, that is 2 into s plus 2 by s plus 2 whole square plus 9 minus Laplace inverse of 7 by s plus 2 whole square plus 9. 9 means simply write 3 square also. Okay, that is Laplace inverse of 2 into s plus 2 by s plus 2 whole square plus 9 minus Laplace inverse of 7 by s plus 2 whole square plus 9. Once you observe, after converting each and every term as s plus a form, now it will be converted as the first shifting theorem LHS part. What is the first shifting theorem LHS part? Laplace inverse of f bar of s minus a is equal to what? E power at into f of t. This is the property of the first shifting theorem. Okay, now I'm applying these condition on the above step. See, all of you, here Laplace inverse of, here what is a? From the above step, here I'll convert s plus 2 by s plus 2 whole square. That means here what is a? A as minus 2. Okay, that is Laplace inverse of Okay, that means 2 into s plus a by s plus a whole square plus 9. By using the first shifting theorem, now I'll write that as e power at into f of t form. That means here what is a? That is minus 2. Okay, that is minus 2. That is simply I am writing this e power minus 2t into remaining part as 2 into, okay, Laplace inverse of, okay, s by s plus 2 whole square, I mean s square plus 9 here. Once again I'll write this step here. By using first shifting theorem, by using above property, that is e power minus 2t into 2 into Laplace inverse of s by s square plus 3 square minus for the second part of the answer here. I'll take 7 outside, remaining 1 by s plus 2 whole square plus 9. By using the first shifting property, that means above property, it will convert, okay, e power minus 2t into, okay, Laplace inverse of 1 by s square plus 9, or 9 I'll write simply that as 3 square. Okay, once you observe, after applying the first shifting theorem, how it will convert? E power minus 2t into 2 into Laplace inverse of s by s square plus 3 square minus 7 into e power minus 2t into Laplace inverse of 1 by s square plus 3 square. Okay, for the next step here, directly once you see the first part, here Laplace inverse of s by s square plus a square formula, that is cos at. Here what is a? 3. Okay, here what is a? 3. But once you observe the second part of the this, that is Laplace inverse of 1 by s square plus 3 square. Here what is missing ma? Here, which is in the form of generally Laplace inverse of a by s square plus a square. Here what is a? 3. But here that 3 is missing in the numerator. That's why I'll multiplying and dividing with 3. After that it will be converted as Laplace inverse of a by s square plus a square form. Okay, here what is common once you observe here? That is e power minus 2t is common. E power minus 2t is common, and the remaining part 2 into Laplace inverse of s by s square plus a square is, that is 2 as it is, that is cos 3t minus 7 into e power minus 2t into, here what is missing? 3 is missing. That's why multiplying and dividing with 3, that is 3 into 3 by s square plus 3 square. That is e power 2 I am taking outside, 2 into e power minus 2t into cos 3t minus, here I am taking 7 by 3 into e power minus 2t. After multiplying and dividing with 3, okay, it will be converted as Laplace inverse of a by s square plus a square. What is a here? A means what? 3. That means it is sine 3t. Okay, that is 2 into e power minus 2t into cos 3t minus 7 by 3 into e power minus 2t into sine 3t. Okay, that is the final answer. Okay, or one more step. Here I am taking e power minus 2t common, that is 2 into cos 3t minus 7 by 3 into sine 2t. This is final answer. Okay, is it clear? This is the second question by using first shifting property. Here if you know the basic formulas and the shifting property, that problems are very simple. Next question. Find the inverse Laplace transform of s by s plus 1 whole square. Okay, I'm giving one more question answer here. That is s by s plus 1 whole square. We note that here once you see how we are using first shifting property here. Okay, directly given denominator as s plus a form. But what about the numerator here? Numerator is only s. Okay, for that case, I'm taking s by s plus 1 whole square is equal to, I'm adding and subtracting with 1. That is s by s plus 1 whole square. How I'll convert that? S plus 1 minus 1 by s plus 1 whole square. Once you see, if you are cancelling 1 and minus 1, again we got the same function, right? That's why for our convenience, I'm adding and subtracting with 1. That is s plus 1 minus 1 by s plus 1 whole square. That is simply here I'm taking the next step. I'll write here s plus 1 minus 1 by s plus 1 whole square. That is s plus 1 by s plus 1 whole square minus 1 by s plus 1 whole square. Here once you observe here, 1 s plus 1 and 1 s plus 1 is cancelled. That is 1 by s plus 1 minus 1 by s plus 1 whole square. That is this. Okay, next. See, now applying both sides Laplace inverse, that is Laplace inverse of s by s plus 1 whole square is equal to Laplace inverse of, okay, that is 1 by s plus 1 minus Laplace inverse of 1 by s plus 1 whole square. After applying both sides Laplace inverse, once you observe the first part and the second part, here once you observe what is the first part of this? Laplace inverse of 1 by s plus a form. And the second part also Laplace inverse of 1 by s plus a whole square form. Okay, now apply first shifting property. Okay, by using first shifting property, what is the first shifting property here? Laplace inverse of f power of s minus a is equal to what? E power at into f of t form. Okay, but here what is s plus a? S plus what? S plus a means what? S plus a means here minus 1 as a. Okay, here minus 1 as a. That means I'll write simply this as e power minus t into, next step I'll write here that continuation, that is e power minus t into Laplace inverse of 1 by s minus, this is the property, minus here e power minus t into Laplace inverse of 1 by s square. Okay, e power minus t into Laplace inverse of 1 by s minus e power minus t into Laplace inverse of 1 by s square. Here, what is common? Here, e power minus t inverse is common. Once you observe, this is Laplace inverse of 1 by s minus Laplace inverse of 1 by s square. What is the formula of Laplace inverse of 1 by s? Laplace inverse of 1 by s means what? That is 1. Okay, that is e power minus 2 into 1 minus Laplace here 1 minus Laplace inverse of 1 by s square means what? That is t. These are the basic formulas on inverse Laplace transform. Therefore, the final answer is here. I am writing in the brackets here. Laplace inverse of 1 by s is equal to 1. Laplace inverse of 1 by s square is equal to t. Okay. Therefore, here the answer is e power minus t into 1 minus t. This is the final answer for the third question. Next, find inverse Laplace transform of 1 by s square plus 4s plus 13 minus s plus 4 by s square plus 8s plus 97 plus s plus 2 by s square minus 4s plus 29. Okay, this is very lengthy question compared to the previous one. Okay, then here once you observe 1 by s square plus 4s plus 13 and minus s plus 4 by s square plus 8s plus 97 plus s plus 2 by s square minus 4s plus 29. Okay. See all of you here how I'll convert the question. Okay, that is I'm simply for the first part of the question 1 by s square plus 4s plus 13 minus s plus 4 by s square plus 8s plus 97, and the second part that is, and the third part of the question is s plus 2 by s square minus 4s plus 29. Okay, now I'll convert that as first shifting property. What is the first shifting property again? Laplace inverse of f bar of s minus a form is equal to e power at into f of t form. This is the property. But once you see, observe the question, is there any part as f bar of s minus a or f bar of s plus a form? No. Okay. Then for that, I'll convert that as either f bar of s minus a or f bar of s plus a form. If you are converting that as Laplace inverse of f bar of s plus a means, for that case formula, e power minus at into f of t. Okay. Now, here once you observe, after this step, that is 1 by s square plus 4s plus 9. I'm taking 4 plus 9. Okay. 1 by s square plus 4s plus 4 plus 9 minus s plus 4 by s square plus 8s. Now I'll separate 97. I'll divide that 81 plus 16. Okay. I'll write 97 as 81 plus 16. 81 plus 16 is how much? That is 97 only. Okay. Plus s plus 2 by s square minus 4s plus 4 plus 25. I'll write 29 as 4 plus 25. How much 4 plus 25 has? Again, that is 29 only. Okay. That is, okay. Now I'll write the first part. The first part, s square plus 4s plus 4. What is the formula of that? Again, which is in the form of a square plus 2ab plus b square. Simply, I'll write that as s plus 2 whole square plus 9 minus s plus 4 by, okay, again, once you observe here, s square plus 8s plus 16. Okay, next step, I'll continue that. 8s plus 16 and I'm writing 81. Okay, plus s plus 2 by s square minus 4s plus 4 plus 25. Okay, from that, okay, now I'll write this as 1 by s plus 2 whole square plus 3 square minus s plus 4 by, okay, what is the form of this? A plus b whole square, that is s plus 4 whole square plus, simply I'll write 81 as 9 square plus s plus 2 by s square minus 4s plus 25, that is s minus 2. Okay, that is s minus 2 whole square plus 5 square. Once you observe the numerator part for the third part here, okay, s plus 2, now I'll convert that as also in the s minus a form. How I'll convert that? Okay, here s plus 2, that now I'll take that as minus 2 plus 4. Is there any changes with taking like this? S minus 2 plus 4. Minus 2 plus 4 is equal to how much? 4 only, 2 only. Right? Minus 2 plus 4 is equal to 2. Why I am taking like this? Once you observe here, numerator and denominator both are in the s minus a form, means easily we are writing the shifting property. That's why I am taking that as s minus 2 plus 4 by s minus 2 whole square plus 5 square. Okay. Next step, that is 1 by 3 into, okay, what about the previous steps here? Once you observe here, what is 1 by s plus s square plus a square form minus s plus 4 by s plus 4 whole square plus 9 square plus s minus 2 plus 4 by s minus 2 whole square plus 5 square. Okay, next steps, that is, next step, that is 1 by 3. Okay, in the previous step, in the first part of the answer, here there is no 3. Okay, why I am taking here multiplying and dividing with 3? Why? Because here the first part is, okay, a by s square plus a square form. That's why I am taking here 3 by 3. Okay, minus Laplace inverse of s plus 4 by s plus 4 whole square plus 81. There is no changes here for the second part. Here in the first part of the answer only I am taking multiplying and dividing with 3, that is 1 by 3 into Laplace inverse of 3 by s plus 2 whole square plus 3 square. Okay, minus Laplace inverse of s plus 4 by s plus 4 whole square plus 9 square. Next continuation, plus Laplace inverse of s minus 2 by s minus 2 whole square plus 25, and here s minus 2, what I'm writing in the previous step for the third part, s minus 2 plus 4 form. That's why here I'm writing 4 by s minus 2 whole square plus 5 square. Okay, 5 square or 25, whatever it is. Okay, this is equal to here again, that is 1 by 3 into 1. Once you observe here in the last step here, 4 by s minus 2 whole square plus 5 square, again I'll convert that as a by s square plus a square form. Okay, that means here what is missing? 5 is missing. That's why I'm multiplying and dividing with 5 for the third part. That is 1 by 3 into, now this is Laplace inverse of a by s square plus a square means what? That is e power minus 2t into remaining as sine 3t. By using first shifting theorem, here s plus a, that is a means minus 2t, and the remaining as Laplace inverse of a by s square plus a square, that is sine 3t, minus Laplace inverse of s plus 4 by s plus 4 whole square plus 9 square. What is the form of that? That is also first applying first property of the shifting, that is e power minus 80 into remaining as s by s square plus a square, that is cos 90. Okay, and next plus Laplace inverse of s minus 2 whole square by 25 or s minus 2 plus 5 square, which is in the form of, again here what is a 2, that is e power 2t into s by s square plus a square, that is cos 5t, plus, okay, next plus 4 into 5, here what is common, that is 4 by 5 I am taking outside. For the remaining part, Laplace inverse of a by s square plus a square, that is, okay, first I am writing shifting property, that is s minus a means e power 2t, and the remaining as a by s square plus a square, that is sine 5t. This is the final answer for the fourth question. Okay, these are the related problems on first shifting property. Next question. Find the inverse Laplace transform of s plus 2 by s square minus 4s plus 13. This is also same as previous question. Here s plus 2 by, how I'll write the numerator part, that is s minus 2 plus 4 by s minus 2, s square minus 4s plus 13. I'll write simply s minus 2 whole square plus 9. What I discussed in the previous problem, same procedure here also I'm applying. That is s minus 2 plus 4 by s minus 2 whole square plus 9, that is s minus 2 by s minus 2 whole square plus 9 plus 4 by s minus 2 whole square plus 9, that is s minus 2 by s minus 2 whole square plus 9. Here again for the second part of the answer here, that is 4 by s minus 2 whole square plus 9 means here what is missing, which is in the form of a by s square plus a square. Here missing is a in the numerator. That's why I'm multiplying and dividing with 3. Why? Because here the denominator 9 means 3 square. That means s square plus a square means a. A is here 3. That means I'm multiplying and dividing with 3. That is s minus 2 by s minus 2 whole square plus 9 plus 4 by 3 into 3 by s minus 2 whole square plus 9. By using first shifting property, again it will convert Laplace inverse of s minus 2 by s minus 2 whole square plus 9 plus 4 by 3 into Laplace inverse of 3 by s minus 2 whole square plus 9. This is equal to, again, what is the first part here, which is in the form of a by s square plus a square. First I am applying the shifting property. Here a means 2, that is e power 2t into cos 3t plus 4 by 3 into, here I am multiplying and dividing with 3, that is 4 by 3 into e power 2t into remaining as a by s square plus a square, that formula is sine 3t. Therefore, here what is common in both the terms? E power 2t is common, that is e power 2t into cos 3t plus 4 by 3 into sine 3t. Okay, this is one more question on first shifting property. Next, inverse Laplace second shifting property. Okay, up to now what we are discussing, Laplace, okay, shifting property, Laplace of first shifting property and that related questions. Now we will discuss inverse Laplace transform second shifting property. What is the property here? If Laplace inverse of f of s is equal to f of t, for that case Laplace inverse of e power minus sa into f of s is equal to g of t. Okay, Laplace inverse of e power minus sa into f of s is equal to g of t. Where what is g of t form? Here the g of t function as if t greater than a, for that case function as f of t minus a. For t less than a, for that case I'll write that as 0. Okay, or Laplace inverse of e power minus sa into f of s is equal to g of t minus a and h of t minus a. What is h of t minus a? H of t denotes Heaviside unit step function. Okay, if you are using second shifting property, the formula of g of t is equal to f of t minus a for t greater than a, 0 for t less than a, or simply write g of t minus a into h of t minus a. What is h of t minus a? That is one unit step function. Okay, next shall I? Now I'll explain one question on that related. Find inverse Laplace transform of e power minus pi s by 2 by s square plus 1 minus e power minus pi s by 2 by s square plus 1. That is here, first I'm taking the given question, I'll take e power minus pi s by 2 as outside and the remaining as 1 minus 1 by s square plus 1. Once you observe which is in the form of what? Which is in the form of second shifting property. Once I am taking the previous slide, once you see Laplace inverse of e power minus as into f of s is equal to what? G of t. Once you observe, okay, this which is in the form of e power minus pi by 2 into f of s. What is f of s here? That is minus 1 by s square plus 1. What is f of s? Minus 1 by s square plus 1. Then where here I am writing by using second shifting property, simply this is, that is, okay, e power minus pi by 2 into f of s. Here f of s as minus 1 by s square plus 1. What is the formula of Laplace inverse of 1 by s square plus 1? A by s square plus 1 as sin t. Right? Okay, sin t. For that case, I'm writing here in the exponential form in the given question. What is the exponential form? S coefficient as minus pi by 2. Now I'm using the second shifting property. Now I'll convert that as g of t is equal to f of t minus a. Okay, f of t minus a. Here what is f of t? 1 by s square plus 1. Formula as sin t. Okay, Laplace inverse of 1 by s square plus 1 as sin t, that as f of t. But I am converting that as g of t. What is the form of g of t? G of t is equal to minus of sin of t minus pi by 2 for t greater than pi by 2. Here how you got pi by 2 from the given question? Exponential form as s coefficient as minus pi by 2. That is minus of sin is t of minus pi by 2 for t greater than pi by 2, 0 for t less than pi by 2. Here in the question only minus is there, that's why I'm writing here minus of t minus pi by 2 for t greater than pi by 2 and 0 for t less than pi by 2. Okay, this is answer for this first question, or simply write that as, okay, minus of sin t minus pi by 2 into h of t minus pi by 2. What is h of t minus pi by 2? That is one unit step function. Okay, that means, okay, unit step function up to here also correct answer. Otherwise, write this step also. That is minus of sin t of minus pi by 2 plus into h of t minus pi by 2. But here once you observe sin of pi by 2, is how much? Cos t. Okay, sine of minus t as minus sine t, but here minus into minus plus, that is sine of minus theta as minus sine theta, but here sine of minus pi by 2, that is minus cos t, and minus into minus plus cos t into h of t minus pi by 2, where h of t denotes the Heaviside unit step function. This is the first question on the second shifting property. Okay. Next, I'll explain one more question. Find inverse Laplace transform of 2e power minus s by s cube. Once you observe here, directly the question has f of e power minus at into t form. Once you observe the property, Laplace inverse of e power minus a into f of s, right? Laplace inverse of e power minus as into f of s. Here e power minus as into f of s form. Simply I am writing 2 into e power minus s into 1 by s cube. And what is the formula of Laplace inverse of 1 by s cube? That is t square. Therefore, by using second shifting operator, directly Laplace inverse of 2 into e power minus by s cube is equal to g of t. But what is g of t? Here already we know that Laplace of 1 by s cube as t square. For that I am using in the function g of t, that is t into t square means what? T minus 1 whole square. What is 1 here? E power minus x coefficient as 1. That's why I am writing here 2 as it is. That inverse Laplace transform of this as t square. That's why I am writing t minus 1 as the exponential coefficient. That is 1, t minus 1 whole square for t greater than or equal to 1. 0 for 0 less than or equal to t less than or equal to 1. Okay. In the given question, exponentially is there, means for that case directly apply second shifting property of the inverse. Next one, change of scale property. It is very simple once you observe what is the property of this change of scale property. Laplace inverse of f of s is equal to f of t. Then Laplace inverse of f of s by a is equal to a into f of at. Laplace inverse of f of s by a is equal to a into f of at. Okay, directly I am applying the property on the first question. Find the inverse Laplace transform of s by 2 whole square plus 4. Okay. Simply we know that before applying the change of the scale property for the given question, first I am using Laplace inverse of s by s square plus 4. 4 means 2 square. What is the formula of that? Cos 2t. Okay. Write down this in the brackets. After that, I am applying first change of scale property for the given question. That is Laplace inverse of s by 2 whole square plus 4. Okay, here what is missing? Okay, here I am multiplying and dividing with the 2. Why? Because the given question, I'll convert Laplace inverse of f power of s by a is equal to a into f of at form. A into f of at. But here a is missing. For that, I'm multiplying and dividing with the 2, that is 2 into Laplace inverse of s by 2 by s by 2 whole square plus 4. Now, directly the question will be converted as Laplace inverse of f of s by a form. Okay, Laplace inverse of f of s by a form. That is already here 2. By using the change of scale property, here what is a? Again, a means 2, and the remaining as s by s square plus 2 square form, that is cos 2t. That is cos of 2 into 2t. That is 2 into 2, 4 into cos 4t. This is the final answer. Very simple method for the change of scale property. Before, okay, first the given question, now we have to convert that as Laplace inverse of f of s by a. Okay. Okay. Thank you. We will discuss the related questions on the next class. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.